Alright, so here's a continuation of 8-3. This is the tutorials video. So let's go ahead and do this. Number 1, can you conclude the triangles are similar? If so, write a similarity statement and name the postulate or theorem you used. If not, explain. So I've got 3 sides here. So I'm going to use side, side, side. I need to set up my corresponding sides. So I can see FE corresponds with AB. 3 corresponds with, BC corresponds with DE, and DF corresponds with AC. So I'll set those up. AC over DF equals 4 over 6. AB over FE equals 2 over 3. And then BC over DE equals 3 over 4.5. And simplify. So this number is 2/3. If you reduce it, this is already 2/3. This, if I take this number and I reduce it, it's 2 times 1.5 over 3 times 1.5. These will cancel out. This also is 2/3. So these are similar. So ABC is similar to triangle DEF. Okay, by the side, side, side similarity. All right. Oh, well, let's do number 3 already. So if possible, find the similarity ratio. Number 1 was 2. It was a 2 to 3 ratio from the small to the big. If you're going from the big to the small, it's a 3 to 2 ratio. All right, next triangle. So here I have an angle, a side, and a side. The angle is included between those two sides. Here I have an angle and a side and a side. Be careful though, because this angle is not included between the two. Therefore, I cannot use my side angle side similarity theorem. So I can't prove if they're similar. All right, I'm gonna flip the page. All right, 4 through 9. Are the triangles similar? If so, write a similarity statement and name the postulate or theorem you used. If not, explain why. Okay, let's see what we have here. These are vertical angles. And, ooh, this is good. So these are parallel lines, right? So that means I can draw these out like that. And that makes this angle the same as that one, because they're both, these are called alternate interior angles. So this is angle similarity, because I have 2 angles that are congruent inside these triangles. Good. Oh, write a similarity statement. Okay, so G, F, G, H is congruent to triangle J, H, K. Or, sorry, H, J, H, J, K. Just thinking of my alphabet here. Alright, next one. I have a side, an angle, and a side. And then I have a side, an angle, and a side. So that fits the SAS congruence. First of all, I'm sorry. We need to check to see if these are the same ratio. So this is a 3 to 6 ratio. 3 to 6 right here. Sorry, my big hand's in the way. 4 to 10 is a 2. That's not 3 to 6. So this is 1/2. This is not 1/2. So these are not similar. So be careful on that. All right, number 6. So I have angle A is congruent to angle A for it's reflexive, itself. And then, so this would be 20 and 25. Okay, so that means that the small triangle, AX, corresponds to the bigger side, AB. The smaller side is 20, the bigger side is 45. And then AY must correspond to AC. So that's 25 to 55. And let's reduce these. So both of these numbers have a 5 in them. So I'm going to take out the 5. This is 5 times 4 and 5 times 9. I'm looking at 20 over 25. So this is a 4 over 9. And then this is 5 times 5 over 11 times 5. So this one is a 5 over 11. So that means that these are not, because their ratios are different, these are not similar. It's funny because they look like they would be similar, right? But what's going on here is that actually this is 5 over 11, which is slightly smaller than 4 over 9. Smaller? No, slightly larger, I'm sorry. That means that this line is not perfectly level. It's actually tilted downwards. It's just trying to fool you. So that's why checking the ratios is very important with these. Number 7, angle A is itself, again. So we need to check to see if AP is congruent to AB. So that's a 3 over 8. And then we need to check to see if AJ is the same as AC. So that'd be 2 over 5 1/3. Yeah, 5 1/3. So this is 3/8. 5 1/3. Okay. I'm going to use a calculator. I don't feel like dealing with the fractions. So 3/8 is equal to 0.375. So that means that this smaller triangle, or this side, is 0.375, the larger side. And then 2 divided by 5.33 is 0.375. And some added extras, but I approximated with 0.33. These actually have the same ratio, so these triangles are similar by side angle side. And you could say that triangle, where shall I write this? Triangle BAC is similar to triangle PAJ. Alright, I'll let you guys do number 8. It looks very similar to these other ones. Let's do number 9 together. JKL and PRQ. So let's go ahead. First we need to rotate this one like that. So we're going to try and use side, side, side similarity because we're given 3 sides. The hypotenuses are going to be our candidates for similarity. So that's a 40 over 60. PR would correspond with the next biggest side. So PR similar to KL. That's a 30 over 45. And then RQ, so this side right here, similar to the smallest side, JK. That's a 22 over 32. This stinks. I really wanted this to be so. Okay, because this is a 2/3 ratio. This is a 2/3 ratio. This is not a 2/3 ratio. So you can take out 11 out of 22. So it's 11 times 2. And then you would need 33. So this is not 2/3. So these are not similar, because this last one is not a 2/3 ratio. Okay, let's move on. Number 10. Example 3. Explain why the triangles are similar, then find the value of x. I actually like doing these. These are kind of fun. Explain why they're similar. Okay, so we've got two triangles here. And if I took this big one and I rotated it like that, I would see that this angle corresponds with this angle, and this angle is congruent to this angle. So I have angle-angle similarity. That's why the two triangles are similar. And now I just need to find the value of x. Well, I can set this up like this. 3 over 4.5 is equal to 5 over x, and then I'll multiply, cross-multiply. 3x equals 22.5. I think. Let me double check that. Oh yeah, on point. And then divide by 3. X equals 7.5. Very nice. Another way is to see that the ratio here is 2 over 3. Or the big one is 1.5 times the smaller one, so I just take 5 and multiply it by 1.5. And you'll get 7.5. Alright, next one. What are we looking at here? I've got 110 degrees here. That means that this guy here is 70. And that's 70, that's 70. This angle is equal to itself. So this is really two triangles like this. If I pull them apart like that, this angle, these two are congruent. These are both 70, so those are both congruent. So again, I have angle-angle similarity. And then this small side is 3. This side down here is going to be 6. It's 3 plus 3. And they say this is 5. Well, 3 is half of 6. That means that x must be half of 5. So x equals 2.5. Okay, number 12. That's at 24. So here I have vertical angles. So I'll just throw those down already. Sorry, my nose is going. Let's see what we have. Okay. This angle is congruent to this angle. These are congruent. Therefore, again, I have angle-angle similarity. I need to find the value of x. 14 corresponds with 24. So 14 over 24 is the same as the smaller side x over 22. And before I, let's go ahead and do that. So we'll cross multiply. Sorry guys, I like to think aloud. 14 times 22 is 308. So we get 308 equals 24x. We'll divide 308 by 24. We get some weird number, 12.8333. That's actually 12 and 5/6. Okay, so 12 and 5/6. That's the length of x. Alright, next one. They really like these triangles within triangles, don't they? Okay, so let's check it out. These are parallel sides. That means that these are corresponding, so these angles are the same. And that means that these are also the same. These are corresponding. So again, I have angle, angle, similarity. And that means that this smaller triangle, side length 6, larger one's going to be 6 plus 2, that's 8. So we're looking at a 3 to 4 ratio. That means that the larger triangle is going to be 4/3, the 4/3 of 9, or 9 is 3/4 of x. So if you multiply 9 by 4/3, you should get, anyone? I'm trying to pull the teacher from Ferris Bueller. Anybody? Anyone? Anyone? And then he says, whatever. 12. X equals 12. Getting called. I'll call him back. Okay. Next one. How are these congruent? Okay, well this angle is the same. These are parallel, meaning this is the same as that. They're all this. Too easy, man. Too easy. Again, angle, angle, similarity. 5 is a third of 15. That means 4 is a 1/3 of x. So what number divided by 3 would get you 4? 12. X equals 12. Last one, we have parallel lines. So then these are corresponding. That's the same again. I have angle, angle. 12 over 18 is 2 over 3. And then that's going to be similar to x over x plus 7.5, because it's going to be the shorter side plus 7.5 will get you the longer side. So then we're going to cross multiply. 12 times x plus 7.5 equals 18x. And then we distribute. This will get messy. 12x plus 7.5 times 12 is 90 equals 18x. So I get 90 equals 6x, x equals 15. You could have done that in your head too. Yeah, that's alright though. We're using our tools. Cross multiplication is a very good tool. Alright, numbers 16 through 19. Explain why the triangles are similar, then find the distance represented by x. Okay, so what do we have here? I have vertical angles. I've got a side here, a side here, a side here, a side here. If they are, if this side here, 6 corresponds with 9, and 4 corresponds with 6, these are both 2/3, so they're similar ratios. So these triangles are similar by side angle side similarity. And then you're going to have x is 1.5 times 8, okay, or 8 is 2/3 of x. 8 is 2/3 of x. So then x is going to be 12. Sorry if I'm doing this a bit fast. If you're ever wondering how I get something, try it out for yourself. I'm always going to say this. Try it out for yourself. Work it out with a calculator. And you should be able to be happy with your results. Check your answers with what I get. Alright, next one we have a right angle. This angle is congruent to itself. Okay, so we have angle similarity, and x is the length of the, or sorry, it's the width of the pond here with the geese in it. So the smaller triangle, so imagine a person, they pasted out, it's 90 yards to this spot, and then 110 yards to that spot. And then they also paste it from here to the far end of the pool, or the pond, would be 180. So that means this larger triangle is twice the size of the smaller one. So we're going to do 90 over 180 equals 110 over x. Well, if the larger triangle is twice the size, that means that we just take this guy right here and multiply it by 2. That means the pond is 220 yards across. Number 18, this is exactly like the one in the example, so I'm going to skip it. Number 19, okay, so let's zoom in here. Get real close there. I'll focus it. There it goes. Okay, so we're going to explain why these are the same. So these are verticals, and if you took this triangle and you rotated it about this point 180 degrees, you would see that these are actually the same triangle, and that's going to be 15. I don't know the length of the hypotenuse, but this guy is 20 feet. So these are similar by angle similarity because I've got two angles the same. So I know that this length is 120, this length is 20. So this length is 6 times that of 20. 20 times 6 is 120. That means that x would be 6 times the length of 15. So you can find the distance of your river. So using similar triangles, all I need to do is just do 15 times 6. And I'll get 90. So my answer is 90 feet. That's how far across the river is. Pretty cool use of triangles here. Let's see, I think the rest here is... So go ahead and you get to work on these by yourself. I'm not going to do these. Have fun. Alright guys, I'll see you in the next video. Bye.